Hello, Precalculus students, to our another day of the polar unit that we've been working on these past previous lessons. We've talked about this idea of converting coordinates from either polar to rectangular or vice versa. Today we're going to get into this idea. We're still going to be talking about this idea of converting, but this time we're going to talk about how to convert equations between polar and rectangular. But before we get to that, let's try a little bit of a warm-up. Hopefully you try this out on your own first before watching through the video and looking through the solution. So let's do that. All right, so let's see what we got here. We have plot the following polar coordinate on the grid, then answer the subsequent question. So 1a. So 3, 3 pi over 4. All right, let's try this out. So if we remember that this first number is r, and the second number is theta. So r is your distance from the center of the grid, and theta is just the angle measured counterclockwise. So 3 pi over 4 is over here. Hopefully you see it. And we want 3, so 3 units away from the center. All right, so 1, let me do that. So we got 1, 2, and 3. So that is where our point is going to be. So 3, 3 pi over 4. All right, so there you go. There's our point. Now B, find 4 other coordinates that would end up on the same point as part A. All right, so find 4 other coordinates that would end up on the same point as part A. Well, let's do probably what is the easiest trick that we can use to always guarantee us that we can find another point or another coordinate that is the same point on the grid is let us add or subtract 2 pi to the original angle. Because remember, if we add 2 pi, you end up in the same spot. And if you subtract 2 pi, you end up in the same spot. Because recall that 2 pi radians is a full revolution around the circle. So 2 pi radians, whether you add it or subtract it, is always going to bring you in the exact same position on the circle. So let's do that. So first let's try adding 2 pi to the original angle. So I'm going to do it up here. So 3 pi over 4 plus 2 pi. So that's the same thing as doing 3 pi over 4 plus 8 pi over 4. Okay, 8 over 4 is the same thing as 2. So that gives us 11 pi over 4. So that would be one additional coordinate, 3, 11 pi over 4. All right. So we tried adding 2 pi. Let's try subtracting 2 pi. So once again, we're still going to do the 3 pi over 4. Let's do minus 2 pi. So that would be the same thing as 3 pi over 4 minus 8 pi over 4. So that gives us negative 5 pi over 4. So negative 5 pi over 4. So that would be another coordinate that would be in the exact same spot. So negative 5 pi over 4. So once again, all we're doing when we're adding or subtracting 2 pi, we're just going around the circle one full revolution, whether we're going clockwise or counterclockwise to end up in the same spot. Okay, well, we can always use this trick if we keep our R value the same, right? So we kept our R value, kept the 3 the same. So we can always use the trick. We can always use that trick if we keep the R value the same. What if we change the R value? What if we change it to a negative? So let's write it as negative 3. So negative 3. Well, if we change it to negative 3, recall when your R value is negative, that means you're counting in the opposite direction away from the center. So instead of counting 1, 2, 3, you would count 1, 2, and 3. So this is where we want to be in order to get to this side, right? Okay, well, if we look at our angle here is 7 pi over 4. So that's going to be our first one. Our first one's going to be negative 3, 7 pi over 4. So negative 3, 7 pi over 4. Because if we took this, backwards, 7 pi over 4 would be here. And since our R value is negative 3, we wouldn't count 1, 2, 3. We would count 1, 2, and 3 in the opposite direction since it's negative. So that works. And now we can just use our trick again. If we keep the R value the same, we can just add or subtract 2 pi. So let's just subtract 2 pi. So let's take 7 pi over 4 and let us subtract that 2 pi, which remember is just the same thing as doing or subtracting pi, 8 pi over 4. So that gives us negative pi over 4. So that would be an answer. That would be another coordinate that would be in the same spot. Okay? There'll be another coordinate that would be in the same spot. And just a check to make sure that works. Negative pi over 4, this is where positive pi over 4 would be. So 1, 2, 3 spaces in the counterclockwise direction. So negative pi over 4 would be 1, 2, 3 spaces in the clockwise direction, which is exactly where we want it to be, because this would immediately take us to the other side. Since it's negative 3, it would be 1, 2, 3. It would be 1, 2, and 3, which is where we want it. So those would be our 4 other coordinates that would end up in the exact same spot on the grid. And once again, we can find many more than 4. All we would have to do is just continuously add or subtract 2 pi, and we would just keep on ending up in the exact same spot. So that's just a little bit of a warm-up. Hopefully you guys got the correct answers. Your answers might be different for this problem because, once again, you can just add or subtract 2 pi, and you could always get additional answers. All right. So that's part B. So our objective for today. So I can convert equations from polar to rectangular and vice versa. So more specifically, today we're going to focus on being able to convert an equation that's in polar form, so in terms of r and theta, and rewriting it in rectangular form. So that's what we're going to be focusing on today. And then our next lesson, we're going to do the reverse from rectangular to polar. Okay. All right, so the approach that we're going to take today is going to be very similar to our previous lessons where we converted points from rectangular to polar and vice versa. So we're going to be using the same formulas that we learned in the previous lessons, but this time we're going to be working with equations, okay? So goal. For example, if we're given an equation in terms of r and theta, we want our final answer to be in terms of x and y. We want our final answer to be in terms of x and y. And then vice versa. If we started with an equation in terms of x and y, we want our final answer to be in terms of r and theta. But once again, today, we're just going to be focusing on starting here and going to here. So that's what we're going to be focusing on today. So once again, just to recap, what are those 4 formulas that we learned in the previous lessons? So they were the following. We talked about x being equal to r, times cosine of theta. We talked about y is equal to r times sine of theta. Then x squared plus y squared is equal to r squared. And finally, tangent of theta is equal to y over x. So those were the main formulas that we talked about. The 4 formulas that we've been using in order to convert points, but now we're going to use these formulas to convert equations. And recall, the way we got each of these formulas, we derived each of them by using a right triangle to determine the relationship between the x's and the y's and the r's, thetas. So example 1, we're going to look at a and b first. So r is equal to negative 10 and r is equal to 5. Well, let's see. We don't have any equation out of those 4 that we just talked about on the previous slide. We don't have any equation that just has an r by itself, right? That just has an r by itself. But we do have an equation that has an r squared by itself, right? We have this equation, x squared plus y squared is equal to r squared. Well, we have an r here, we don't have an r squared. Well, how do we turn an r into an r squared? Just square both sides. Okay, so we're going to square both sides of this equation. So if you square r, it just becomes r squared. And if you square negative 10, that becomes positive 100. Okay, now why did we just square both sides? Well, we squared both sides because now we can use this identity. Since r squared is equal to x squared plus y squared, we can make that substitution. So instead of writing r squared, I'm going to write x squared plus y squared equal to 100. Okay? So once again, I turn this r squared into an x squared y squared because that is what they are equal to. R squared is equal to x squared plus y squared. So that means if I ever see an r squared anywhere in my equation, I can replace it with an x squared plus y squared, if appropriate. So that is all we would have to do for this problem. That is all we would have to do. Now, just to, I guess, point out how do we know we're done. We know we're done because our equation just has x's and y's in it. Recall, if you start with a polar, so an equation in terms of r and theta, you know you're done when your equation just has x's and y's in them. That's how you know you're done. That's how you know you're done. All right. So now let's look at B. So B is just like A. We have r is equal to 5. So we're going to square both sides. So r squared, let me do the red, r squared is equal to 5 squared, and 5 squared is just equal to 25. And once again, since r squared, we have that identity, is just equal to x squared plus y squared, I'm just going to replace that r squared with that expression. And ta-da, we're done. Once again, our equation now only has x's and y's, no more r's or thetas, and that is how we know we are done. So once again, we started with a polar, that r variable, we ended with rectangular, x's and y's, so we're done. C and D. So now we don't have r's anymore, now we have thetas. Well, out of the 4 formulas, once again, remember those 4 formulas, there was only one formula that had a theta in it. There was only one formula that had a theta in it, and the only formula that had a theta in it was this one. Tangent of theta is equal to y over x. The other 3 formulas did not have a theta in it. This was the only one. Well, we have theta, but we want tangent of theta. Well, all we have to do is just take tangent of both sides. Once again, as long as I do it to both sides, perfectly okay. Right? As long as I do it to both sides of the equation, it's perfectly legal. Well, tangent of theta is just equal to y over x, because once again, that is the identity that we have up here, right? Tangent of theta is just equal to y over x. Tangent of pi over 4, on the other hand, well, if we look at our unit circle, remember tangent is y over x, if we look at our unit circle, pi over 4 would give us radical 2 over 2 divided by radical 2 over 2. When you divide a number by itself, you just end up with 1. So that would be our answer. Once again, no more thetas, right? Our equation started with a theta, ended with just y's and x's. Now let's just pretend the question asked us to solve for y, or to get y by itself. Well, if we wanted to get y by itself, all we would have to do to both sides of this equation is we would just have to multiply by x to both sides of this equation. So multiply x both sides of this equation, that x cancels out, y is equal to 1 times x. So let's just say that was what the question was asking you to do to get y by itself, or to solve for y. That's how you would do it in this situation. Otherwise, you would be done with y over x is equal to 1. Now D. Theta is equal to 2 pi over 3. Well, we're going to do the same thing. We're going to do the tangent of both sides. Tangent of both sides. All right, so 2 pi over 3. Once again, tangent of theta is equal to, sorry about that, y over x. And tangent of 2 pi over 3, if we look at our unit circle, remember y over x, is going to be equal to radical 3 over 2 over negative 1/2. Remember, when you divide by a fraction, that is equivalent to multiplying by the reciprocal of the denominator. So since our denominator is 1/2, the reciprocal is 2 over 1. These 2's cancel out. The negative stays there, so we're just left with negative radical 3 over 1, so just negative radical 3. So the other side is just negative radical 3. And once again, if we wanted to get y by itself, or we wanted to write this equation as y equals, we would multiply both sides by x, so we would be left with y is equal to negative radical 3 times x. So that would be our final answer for this problem. That would be our final answer for this problem. All right. So once again, not too tricky. You just have to make sure you use the correct formula, and in this case, we ended up using this identity to convert our formula into, or our equation into rectangular. We're going to skip E and F because those are rectangular, and we're going to save that for our next lesson. So now let's look at G and H. So R is equal to 2 cosine theta, and r is equal to 3 sine theta. Well, this is similar to A and B, or they look similar to A and B, so let's try the same strategy. Let's square both sides. Well, if we were to square both sides, this would become r squared. Well, that's good. But then the other side becomes 4, right, because 2 squared is 4, and cosine squared of theta. Well, let's see. Did any of our formulas have a cosine squared in them? Fortunately, they did not. None of our formulas had a cosine squared in them. So this strategy that we used in A and B is not going to work out this time around. Well, let's see. How else could we make an r into an r squared without squaring both sides? Well, another way we can turn an r into an r squared is if we multiply it by r. So let us multiply both sides of this equation by r. Let's multiply both sides of this equation by r. So once again, we still end up with that r squared. And on the right side, you'll notice we end up with a 2r cosine of theta, right? I could just move that r in front of the cosine since it's multiplication. The order of the terms does not matter. Well, why is that helpful? Well, we know, based upon A and B, that r squared is just x squared plus y squared. And r, on the other hand, r cosine theta, we have this formula we can use now. X is equal to r cosine theta. So r cosine theta is equal to x. So I'm going to replace this r cosine theta with an x. So once again, I replace the r cosine theta, with an x because that is what one of our formulas told us they were equal to. Okay, so I replace the r cosine theta with an x. So once again, similar to A and B, because we start out with this r, but this time instead of squaring the r, we have to multiply the r by itself. So multiply the r by an r to both sides. So h is going to be basically exactly the same. All right, so we got r times r is equal to r sine theta times r. So r squared is equal to 3r times sine of theta. R squared is equal to x squared plus y squared. R sine theta, we also have a formula for that. Y is equal to r sine theta. So r sine theta is just going to become y. Okay, so r sine theta just became y because once again, that is what they are equal to. They are equal to each other. So we can just substitute one for the other. And that's it. So as you can see, based upon, how A and B went and now how G and H went, whenever you're given R, sometimes you have to square it. This time we had to multiply both sides by R to get our desired result. So you have to watch out, once again, we easily tried out squaring and saw that didn't help. So sometimes there might be a little bit of what's the word I'm looking for here? Some trial and error to figure out exactly which path works. With practice, hopefully, when you see a problem like this, you immediately know, oh, I got to multiply by r, or oh, I got to square it. Got two more here, so I and j. So this one looks similar to G and H, but you'll see it a little bit different. So instead of sine and cosine, we have cosecant and secant. Well, hopefully you remember what cosecant and secant were equal to. Cosecant, if you recall, is a reciprocal. Come on. Cosecant is a reciprocal. Cosecant of theta is the reciprocal of the sine function. So cosecant is 1 over sine theta. And secant is the reciprocal of the cosine function. So 1 over cosine theta. So let's use those identities. So let's rewrite this as r is equal to 4 times 1 over sine theta. And let's get that sine of theta to the other side. Let's get that sine of theta to the other side by multiplying both sides by sine of theta. Multiplying both sides by sine of theta. So we end up with r sine theta is equal to 4, since the sine theta and the 1 over sine theta cancel out. And now we can use that formula that we used in the previous example. R sine theta is just equal to y. R sine theta is just equal to y. So we just end up with y is equal to 4. And the same thing happens in J, basically. The same thing happens in J. Secant is the same thing as 1 over cosine of theta. we can easily move the cosine theta to the other side by multiplying both sides by cosine theta. So we end up with r times cosine theta is equal to 2, since the 1 over cosine theta and the cosine theta cancels out. And now we just substitute r cosine theta is the same thing as x, so we just end up with x is equal to 2. Okay? So you might be wondering, well, how did you know for I and j you had to multiply both sides by sine and cosine respectively? Excuse me. Obviously, practice helps. But another thing you got to ask yourself is, we ended up in this position in both these equations where we had an r on one side and a 1 over cosine in the other. So you always have to ask yourself, well, if I multiply both sides by the trig function, not only does it cancel out, but I also end up with that r cosine or r sine. Okay? Remember, you always... Whenever doing these conversions, you're always trying to manipulate the equations in such a way where you end up with one of these 4 original formulas that we talked about before we began example 1, all right? You always want to manipulate it in such a way where you end up with one of these 4. So for I and J respectively, what we did was... we multiply both sides by sine and cosine so that we can get that r sine and that r cosine and use that substitution for x and y respectively. And just to recap, for each of these problems, we know we are done. We know we are done when there are no more r's and thetas in it. When there are no more r's and thetas, you know you are done. When your equation is just in terms of x and y, you know you are done. So on the next slide, there's some more extra practice that I would have you guys try out because I will be posting the solutions to this extra practice. Now, in the meantime, in addition to the notes handout that I will be posting, I will also be posting a separate handout, a separate extra practice handout, which will be your next assignment until the next time we meet, until our next class. So the separate handout, so not the handout with the notes, the separate handout that I think is titled 6.4 Day 3, Extra Practice, that will be your next assignment, and it will count as extra credit for those who complete it. We're going to use the same protocol as last time. If you complete it, you can send it to me. I can give you some feedback, and you can get your credit. So once again, your next assignment will be the extra practice that goes along with this lesson. I believe it's titled 6.4 Day 3. But I'll be posting on Google Classroom, so you don't have to worry about exactly knowing the name of it. But once again, that will be your extra credit, your assignment, extra credit if you complete it. Hopefully this lesson went smoothly. I hope you guys are enjoying this hiatus that we're on. Otherwise, I hope you guys are staying safe. I hope you guys are staying healthy. I wish that you guys enjoy the rest of your days, and I will see you later.